differentiate this, I want you to remember to times and take. If you can always remember to times and take, that'll help you when you do more complex differentiations, and especially when you do integrations, because when people start learning to integrate, they can get the two things mixed up quite easily. So remember to times and take. I'll show you what I mean. We're going to times the 3 down to the 5. So 3 times 5 is 15. Then we're going to take. So that 3, we take 1. You always take 1 away, so it's going to become 2. Next term, times and take 1 away, so it'll just be 1. In fact, then we don't even need to write that 1. Next, we've got 8x. Now here it doesn't have a power, but you can think about it if you like as having a power of 1. So times and take. When you take 1 away, it'll be 0. And x to the power of 0 is 1. Anything to the power of 0 is 1, so that term, we can just get rid of that. It will just be 8. So in general, if you've got a number times a letter and you're differentiating, you just lose that letter and you get the number left. If we differentiate 3, similarly, it doesn't even have an x, so that will completely vanish. And that's all we're left with. So every time you're kind of losing a power of x. So now we've differentiated. To show that we differentiated, the language we use is actually dy by dx. And that's just saying we've differentiated y with respect to x. So that x on the bottom is saying that's the variable we've used there. Okay, I'm going to give you 6 examples now. They are going to get more complicated quite quickly actually. So have a go at the ones that you feel you can, and we'll go through them. Okay, so do pause the video here if you want to have a go at some of these yourself. Otherwise we can do this together. The first one we're going to times and take. And the x will vanish and so will 1. Now on this one I've actually used slightly different language. I've used f of x. Sometimes they use y, sometimes they use f of x, so it's good to be exposed to both those languages. If you've differentiated f of x, the way to show differentiated is to do it in a dash, just f dash of x. And that's all that means. It's the same as dy by dx, it's just a different way of writing it. Now, all of these other ones are getting harder. You need to prepare them first before you can differentiate. What I mean by that is you need to write them in a way that they've all got powers. So here, that 4 over x isn't very helpful at the moment. We need to write that as a power of x. So if you need to brush up on your indices work, do watch my other video. Otherwise, you should know that that's x to the power of minus 1. Now we can differentiate. Times and take. Times minus 1 and 4 is minus 4. When you take 1 away from minus 1, you actually get minus 2. Watch out for that. Some people might be tempted to say it's 0, but it's not. Okay, let's carry on. This one needs to be written as powers as well. Okay, well done if you got that one right. Just check you've got your powers okay and the fraction work is alright. Let's carry on. To prepare this one, we need to expand the brackets. Now we can differentiate. No problem. Okay, these last two have got fractions in. These are quite typical sorts of questions to get. You need to prepare them to differentiate, of course. There's a couple of ways of doing this, and my favourite way at the moment is probably to bring that up as a power of minus 1 and then expand the brackets out. Remember when you expand brackets that when you times the terms, you actually add the powers. So that first one will be 3 and minus 1, which is... Now we can differentiate. Okay, well done if you got that one right so far. Let's differentiate. Brilliant, well done if you got that one right. There's a few mistakes you could make there potentially. These fractions aren't particularly easy, so make sure your fraction work is really secure. Well done, that's just a handful of questions, but I do recommend that you Keep practicing those and do some from your textbook or from wherever you get your questions from. Differentiating needs to be right on your fingertips. You need to be able to do it really easily without even much thinking. So keep practicing until you get to that point. Alright, I'm going to give you some exam style questions now. So far I've shown you how to differentiate, but I haven't told you why we differentiate. It's actually a really powerful tool and it's really useful in maths. The biggest reason to differentiate is it gives you the gradient of a graph. So if there's only one thing you take away from this video today, remember differentiating gives you the gradient. So far you've been able to find the gradient of a straight line where the gradient's the same all along it. But for anything that's not straight, for any curve, the gradient's constantly changing. So to be able to find the gradient at any point, you need to differentiate and then put in the x value for where you want to find the gradient. Obviously it will be different for every point on the graph. So differentiating gives you gradient. If we're asked now to find the gradient where x is 8, we need to differentiate. To be able to differentiate this, we need to prepare it. So let's write that as a power of x. And now we can differentiate. We're asked for the gradient where x is 8, so we need to substitute 8 back into this. But to be able to substitute at the moment, it's not on a very user-friendly version. So let's rewrite that with the power back down on the bottom. And we can go one step further and write that x to the power of a third as the third root of x. Okay, now it's written like that, we can use it a little bit easier. So let's substitute 8 in. The third root of 8 is 2, so when x is 8, the gradient is 4/3. Again, this is a question about gradient, so we know we're going to differentiate. This time we're asked to find where the gradient is 0. So let's start by differentiating and then we'll put that equal to 0. We know the gradient is 0, so we can replace that. And now we've got a nice, easy quadratic to solve. If you wrote down this question, you might notice that it actually says find the coordinates, not just the x coordinates. So we need to find the y coordinates as well, so we need to put them back into the original equation to get y. Just be mindful of those negative signs there, and minus number squared is positive, and then you're taking it away so it's still negative. Well done if you got that one right. I haven't figured out how to write mathsy stuff when I type text in here, so I've actually said the second derivative in words, but what that normally means, what you'll normally see is d squared y by dx squared. The second derivative just means that you differentiate twice. So you can actually get the second derivative, third derivative, fourth derivative and so on just by differentiating again and again. So we're just going to differentiate this and then do it once more to find the second derivative. Before we differentiate, we need to prepare it. So that's the second derivative. This is quite a wordy question, so it might be worth taking a screenshot or making a note of the question, so pause the video if you need to. It looks quite complex, but if we just take each piece of information at a time and set up an equation, we'll be okay. So the first piece of information we have is that it passes through 0, minus 4. That's just an x and a y coordinate they've given us, so let's substitute those back in. Those terms will cancel because they're zeros, so we're just left with c is minus 4, which is nice and easy. The second piece of information is about the gradient, so it makes sense to differentiate this. When I differentiate that, I just treat the a and b as numbers, so I almost ignore them. Bring the 2 down to the front, times and take same as I would with numbers. Okay, we're told that the gradient is minus 2 when x is minus a half. There's not a lot more we can do to that right now, so let's move on to the third piece of information and see if it will help us to come back. We need the second derivative, so let's differentiate again. That's got rid of some more stuff, so let's substitute in what we know. We know it's 10 when x is minus a half again. Actually, this doesn't even have an x in, so it'll just equal 2a, which means that a is 5. Now we can go back to here and substitute a back in. And we've done it. Very well done. I hope that's helped you in some way. Keep practicing those, and thanks for watching. Have fun!